Okay, so let's kick things up. So, my name is Nishant Srivastava, and I'm an Android engineer. I've been dabbling into Android libraries and SDK development domain for a couple of years now, and that has led me to look into different things on the open source side and also on the closed source side. Um, this particular topic that we are going to be talking about, Android libraries stop starting up, is going to be focusing on how Android libraries actually start up inside your application and how it affects you as a library developer and as an Android app developer. But even before we start jumping into talking about what these things are actually happening, the question that we should all have is that why are we even discussing this topic? Like, what is so wrong here? What's the actual problem here, right? So, well, in general, there are many ways of writing or initializing an Android library. Some of them are good, some are bad, and then there are some very okayish, depending on how you perceive it. But the general consensus is that it's mostly chaotic. There are so many different ways of doing it, and that basically means that you don't actually know as an Android app developer how these libraries are starting up, and they eventually could lead into particular problems that is not good for your UX for the application in general. And that eventually also leads us to the part where we start questioning that what can be done to unify the fragmentation. Well, to understand this, we need to understand how these libraries are actually initializing. So we'll start with something very basic. I'm pretty sure a lot of people know about this, but we'll iterate over how these libraries or library developers have been iterating over how to initialize their library. The very first one being, and this will be our base example, so I will go down like explaining what the example actually does, is that using a normal class and then its constructor to initialize a library. So in this example that you can see on screen, basically my entry point for the library is a mylib class, which takes a token string in the constructor. Now, what I'm trying to do in this small example is that I'm trying to build a request header. Say, for example, you have retrofit, and then you need to pass an authorization header on it. An authorization header looks something like authorization, colon, bearer, and then it has a bunch of numbers, which in our case is the token string being passed in the constructor. So what we have right now is a class that has a start string property, has an auth header, which is already initialized to start string. And then there is a section here, which is the init block, which is a DSL that is used in Kotlin. And what it does is that as soon as you initialize your class, the init block is executed. And this init block in general is also triggering another function called change token, which takes in a token as a string. And it does the most basic thing. It takes the start string and concatenates it with a token. And then there's a getter for this auth header, which will return authorization colon bearer with the token concatenated to it. Pretty simple stuff. This will be the base example. We'll actually iterate over how other libraries would use this example too. Now, if you had to use this library code that you just wrote, you created a mylib class, you will actually create a property again in your main activity. And you will initialize the usual way. You will say mylib and then pass in a string value. In this case, it's 123 in the constructor. And then eventually, in your when you want to actually get the auth header back, you will say mylib.get auth header. For the sake of completing the whole concept, we also have a function called change token, which if you call that, in this case, we are doing that. The returned value would be authorization colon bearer 456 because change token was called with 456. Pretty simple stuff, very generic. A lot of libraries would do this, and they kind of give you the ability of creating an instance of their entry point class and then start using them. The another version of doing this, and it's a bit modified version of this, is that we got rid of the init block, DSL block that we had in Kotlin, and we are not passing any constructor value in here, but we kind of created a function called init. And this does the same thing, calls a change token function, but it's now a separate function. If you had to use this, you will again be using something similar. You will kind of create a property, but this time nothing is being passed initialized completely by this time, as soon as you created the mylib instance, but rather you specifically have to call .init, with the value, and then go on to do a change token and then retrieve the value. So in this case, again, you will get the output as in your text view.text, you will get the value authorization colon bearer 456. Again, pretty simple stuff. This is kind of something similar that you could also maybe iterate over and take it to a builder pattern, which is like a chaining of methods to build your whole project, your class instance, and then getting the value out of it. That's another possibility that you could iterate over this one. The third way of initializing a library is that, at least in the Android domain, is that you could use a lifecycle observer. Now, when you say lifecycle observer, you actually need to include some dependencies because you're going to be observing the lifecycle of your lifecycle owner. In this case, it could be an activity or a fragment or something else also. So you kind of include the lifecycle runtime KTX and then include the lifecycle common Java 8. What both of these actually allows us to is to start working with lifecycle classes. So now our example changes a little bit. What we are doing now is that now we are kind of implementing the lifecycle observer, default lifecycle observer. And what this allows us to do is that now we have access to onStart, onStop functions, wherein we can call our specific initialization functions. So in this case, we are calling the change token within onStart, and then we are also resetting it back in the onStop, just to make sure that the whole lifecycle is being handled properly. Very normal stuff, but notice that there is no init DSL block or an int function. This is a deferred version of how a lifecycle would initialize, basically meaning that the lifecycle is not initialized as soon as you actually kind of like your library loads up, but rather it will get initialized, or a token change would happen only when the lifecycle goes in the onStart state. There are a few more functions which kind of look the same. There's a change token doing the same stuff. Reset is kind of just bringing the author header back, and then again the getter function that you already have. Now, if you had to use this in your main activity, you will again create a mylib instance, pass in the token that's being the base token, but it's not been yet changed. It can only be changed once the onStart of this activity is called. So in the onResume, we have assumed that the onStart has been called. In the onResume, we can go ahead and get the auth header, considering that a certain change or whatever we requested in the init function of the library is actually taken care of. So that's pretty great, but there's an extra burden on this case. As an app developer, you actually have to now add something called lifecycle.add.observer and lifecycle.remove.observer. This is just so that you can actually hook into the lifecycle. You do this on the onCreate and onDestroy of your, say, activity in this case. But this is extra wiring. Basically, you are asking the app developers as a library developer to go and add extra lines of code just so that your library would get initialized properly. A good example of this, it's pretty old, but this also shows how the libraries have actually been evolving over a period of time, is Picasso. So Picasso actually, at some point in time in 2018, 20 August specifically, there's a pull request that you can check out later on. I will share the slides, then you can check the link out. But basically, Picasso, one library that everyone kind of like have been using for a very long time, set up lifecycle awareness so that they could initialize at the right time, and then everything in the application could actually start using Picasso in a more consistent manner. So this is something that people have been iterating over a time. So initially they did a standard initialization setup, then they did something else like calling an init function, and then Picasso kind of like also moved into using lifecycle awareness. And then Picasso, as of now, it does not do that anymore. It does something else. It's evolved over a period of time. But at some point in time, they did consider this as a functionality to have lifecycle awareness to initialize the library. The fourth way of actually dealing with something like this is that you use a singleton class. This is the most straightforward version that you can do. But in this case, what we are doing is that we are actually modifying our example code in a certain way, because the libraries are evolving, right? And they just don't need 1, 2, 3 as a string as their input, but sometimes they need context. They need to do something within the Android domain also, right? So our functions have changed a little bit. We have the standard object as your singleton class, mylib, has the start string, author, same stuff that we had, but our init function is now changed a little bit. We are now passing in a context, and this context is then used to actually retrieve a string from a strings.xml file. Okay, And then the change token and get auth header, they are kind of the same. Nothing has changed. But the only thing that has changed is your init function, which is referencing a string from the strings.xml file. And that's why we need the context. And in your string.xml file, you actually have something called starting underscore string as a key value, and then you can get the same string that you were actually putting it inside your mylib class earlier. Now, in order to use this in your main activity, you would do the usual way that you would do. You will say mylib because it's now in Singleton, so you're statically now using mylib, and then you will call the init function. This time you're going to be passing application context because you need context to reference to the string.xml file. Rest of the code is kind of the same. You kind of calling check token to change token to say 1, 2, 3, then change token to 4, 5, 6, and then eventually retrieving the value using the Singleton object that you have. But this again is extra wiring. Okay, so this is something that you can't just skip right away. You want the application developer to write this, otherwise the string would never be fetched from the string.xml file. And then even if you call change token or something like that, those things are not going to work out nicely. So you need that authorization :bearer part. That's for starting string. Change token right now is only passing in the token, so concatenation would not work for you. So again, for something like this, we understand that there's an extra wiring. So the library started to like evolve and start looking at different things that they can do to get rid of something, to simplify the life of application developers. A good example of this is Coil, which is an image loading library, again similar to Picasso, but this one is more related to Kotlin side of things, and it uses Kotlin coroutines. And it's backed by it's kind of like doing a lot of things using the Singleton class itself. You can check out the image loader class that they have, which is an object class again, and then there's like a bunch of things that you can actually see how this library does. They took a different pattern over a period of time, and they evolved over a time. Right now, Coil is at 1.0, so it's a very stable stage. So it's a good time to actually look at how the library has evolved over a period of time, and maybe you can take a look at their pull request also. Now, because we are trying to think about this application context and this context, something that maybe how can we get rid of it? Well, apparently there was this one time when you could actually start thinking about this, because Firebase published a blog post which they started talking about using a content provider to feed in the context. This is from 2016. Basically, they kind of publicized how things were happening inside the Firebase SDK itself at that point in time. And the summary of this is basically that they started using content provider to inject context into this. Right. The reason that they could do this is that the content provider is created and initialized on the main thread before all other components, like even before your application class. It's going to run that, and then it will initialize your context right away. Also, content provider participates in the manifest merging at the build time. For application developers, it takes away the init step of library during integration, as in you don't need to initialize the context. Now, also remember, the examples I'm showing are like very smaller version, but in general, your library could be doing a lot of different things by just getting that context, because you need something from, say, your database or something, and then you need to set up something before your library can be used properly. So if we wanted to implement something like this, we need to create a class called mylib_init_provider. And in this one, you kind of extend from the content provider. Then you have access to the onCreate function, which has the context available to you. So this is where you will actually go ahead and init your my library, and then you will pass in the context to it. But that's not it, because you are setting up the content provider. You also need to add a provider tag inside your manifest file. This is specifically happening for your library. This is not happening within your, say, application. You created a class that extender for content provider within your library, and then you, in your library's manifest file, you are actually putting a provider. Now, remember I said manifest merging, so that's where this will actually get merged into the application. So when you create the provider tag, you actually just reference it a name. There's a section where you kind of tell it's like exported, enabled, true, and then the authorities. The authorities is the important part, because there you are using a manifest placeholder. The blue colored $application ID is something that's going to get replaced during the manifest merging phase, and it will be put in with the application package name. What this allows us to do is that it keeps the provider unique, and that is a requirement, that the providers cannot be having the same authority. They need to be unique, so for them to be working within the application. Okay, so how do you actually find out how these providers are getting merged within your application manifest file? So to do that, you actually open up your applications manifest file in your Android Studio. And when you open that, you can actually see a tab that says merge manifest at the bottom. And when you do that, you actually see the full, completely merged version of your manifest file. Within that, you have the ability to start inspecting the providers that have been injected. In this case, my provider is actually the one that I've selected. And this one, notice that the application ID has been replaced with my applications ID, which is github.mishrows.example using content provider to init library dot my library. And you can, on the right side also, you can see that the using content provider to init lib dot my library is where the provider actually comes on. So if you selected that provider, it will show exactly where that provider came from, and it came from my libraries manifest file. So now the things that have changed is that because I have a content provider set up to initialize something, I don't need that line of mylib.init to initialize the application context. I basically don't need that. I can get rid of it, and my code becomes simpler, as in I just start using the library as I want to. I don't even need to care about setting the init function anymore. I just say change token 123, change token again 456, and then I try to get the value out of it, and I get the output as my thresh and PRF 456. So who is using this? Well, out in the open, a lot of libraries are actually using this. Process Lifecycle Owner uses this. The important point to note here is that the reason they need to do it is a valid one. They need to hook into the process as soon as the application is starting, even before your application's class is loaded up. They want to track the life cycle of the process. It's a valid use case, and that's why they're using this. Work Manager, again, is also using this, and it's also a valid use case because they want to understand when to start scheduling things as soon as the application is up, and is it ready to start executing those tasks. That's why Work Manager is also using this. Firebase, which kind of publicized the whole thing, is internally using this in the Firebase common module, and you have access to the same thing. You will see that if you open up their library and open up their Android manifest file, you can actually see the code that I'm showing you for the provider tag in there, and then iterate back to checking out the code for Firebase in a provider class also. It's totally there. Again, they also need to do this because they are doing Firebase analytics, they are doing crash reporting, and it also makes sense for them to do this. Another one to do this, obviously, is Facebook Core. Facebook Core being the base package, which means that if you are doing Facebook marketing, Facebook analytics, this is still getting pulled in. That means Facebook is initializing itself even if you don't want to. So Facebook is something that if, say, for example, you included a marketing library and you basically only need to use it when you open up a certain screen on your application, ideally, that's when the library should initialize and should be available for you to use it. But that's not what's happening. What is happening in this case is that Facebook's version is that as soon as your application is up, Facebook is already active. It can start doing what it wants to do, maybe do some sort of analytics, or maybe get some information from the backend and be ready for you to use it. A bit not in line with how other libraries are doing this for a particular reason, but this looks more like they just want to be ready for analytics or something like that. So content provider is something that our libraries are using. We understand that. But what's the problem? Well, basically, the libraries can auto-initialize even when you don't want to. As an application developer, they're starting up even when you don't want to. And they are getting invoked as soon as the process is starting up, right? Because this thing is happening up, understand that there will be some sort of like a memory overhead also happening. It's going to start allocating memory. It's going to create some objects. It's going to do a bunch of different invocations that it can do as soon as your application is up. And because it's also happening for multiple libraries, they all are going to start up. There is no order of initialization. It's like many of these parallel initializations happening at the same time, which eventually leads us into a situation where we have sluggish UX. As an app developer, you will start seeing that your app startup is super slow. Your startup time has increased. Your animations are going slow. And also important to note is that because we said content providers run on the main thread, all of this is happening on the main thread for you, right? In the end, the general point is that we are basically abusing the functionality of content providers. Content provider in general allow you to do data access from multiple applications, but right now we are using them just to get an access to context. which is not a good thing. It is there, we can't skip it. A lot of libraries, as we saw, are already doing this. Some of the core AndroidX libraries are doing it. And then, so the question that comes out is that how do we tame these bad actors? Like, let's not say all of them are bad actors, because process lifecycle owner, work manager, and say Firebase, they all need to do this. But let's say Firebase is Facebook is something that we wouldn't want it to do. I'm not saying they are bad actors in general, but I'm saying one particular library that is initializing when you don't want it to initialize is something that we want to tame. We don't want them to initialize on their own. Well, the easiest way to do that is to use a merge marker rule in your app's manifest file. Okay, well, the way that you do this is that you kind of define a namespace. In this case, it is XLMNS tools, and then you define the namespace for it, and then you put in the marker for remove node, which is tools colon node equal to, in double quotes, remove. So this is how it looks like. Imagine this is my personal libraries provider, and it's already getting it's getting injected in my application file, right? So what I will do is that I will actually copy paste the provider from the merge manifest file. That's how I can see a libraries manifest provider, the content provider. So I'll copy paste that as it is inside my applications manifest file, and I will add the tools colon remote node equal to remove as the marker on it. And what this does is it actually removes it by the time it reaches the merging phase. Because we are talking about all these merging steps, and like how does it even know by the time it reaches the merger, the main manifest file, we need to look into the manifest merger priority. So this is how the priority is set up. Your libraries manifest file is at the lowest priority. And as you move on to your main manifest file, that's when the priority increases. It goes on to your build variant, which is a higher priority, and then eventually you get the final Android manifest XML file. So what you're saying is that by the time it reaches the main Android manifest.xml file, the provider is already in there. Now, from here onwards, if you actually copy pasted the same provider in your app and added the tools node remove marker on it, it will go ahead and remove it in the next step. So that by the time it reaches the manifest, the final Android manifest.xml file, your provider is gone. And because the provider is actually gone from the manifest file, there's no initialization going to happen. The system doesn't know where the content provider class is and how to trigger it up. So we have been talking so much things about like how to remove them, how to add them, but the final question is how can we fix this, right? So that's when AndroidX Startup comes in. It's also called App Startup. Some people call it Jetpack Startup. I'm just going to call it AndroidX Startup for now, and it's part of the Android Jetpack set of libraries. From their main page, basically the simplest definition is that it implements a straightforward, performant way to initialize components at App Startup. You can find the sources. It's open source. You can definitely go and check it out. And the important milestone for it was that it got stable last year in October 28. So that basically means that a lot of library developers can start using this. So what does it allow you to do? Well, it allows you to initialize libraries without having to define a content provider on their own. Now, there's an emphasis on this. What I'm trying to say is that as a library developer, you don't have to define a content provider for your library. But AndroidX Startup actually does use a single content provider. It's going to make use of the content provider trick still, yes, but that same content provider is going to initialize all the other libraries. Apart from all of this stuff, there's also lazy initialization. There's you can define the order of initialization if you wanted to do that. So if you wanted to set this up, very simple. You add a dependency in your libraries module for your say build.grader file, and then you add AndroidX startup runtime, and then what this gives you access to is that it allows you to have access to initializer class. So initializer class is something, it's like a kind of like a template that maybe if you can think of, and what you're doing is that now instead of creating mylib init provider and then extended from content provider, you are saying mylib initializer and extended from your initializer, right? So the initializer class has two functions. It has create and it has dependencies. You can notice that in the create function, mylib is getting initialized with the context. And then in the dependency section, it is an empty list. Now, dependency is a unique concept that's been brought into the app startup. What it allows you to do is that if, say, for example, my lib init function depended on my awesome lib initialized version of another class, then that's a dependency, right? It's another library that it needs before mylib can initialize. So that's where you actually define the list of other library initializer, and that's what you are doing inside your dependencies. You kind of like have to define the dependency here, and then app startup knows that before it can go ahead and initialize your actual library, it needs to first initialize my awesome library and then go ahead and initialize your my library. So both of them get initialized at the same time, but in proper order. And like in the last case, as you mentioned, app startup actually uses a content provider under the hood. So you still need to add the provider in your manifest file of the library. So in this case, you're adding a provider tag. The rest of the content is actually same. You don't change that. You will see that the Android name has a certain namespace. It has AndroidX startup initialization provider. The authority is set AndroidX-startup. You are saying that the it is exported is set to false, and then you're saying that it needs to be merged in. So you're setting the node for it. The important part that has changed inside the provider tag now is that there's some sort of a metadata, and this is the one that is actually used to find out where your initializer exists. So in this case, my lib initializer is what I want. It always has the value of AndroidX startup. If I have dependencies, I don't have to specify my dependencies in this case. If I tell them the entry point of my library initialization and it has dependencies, it will use the dependency function that we already saw inside the mylib initializer to actually find that and then initialize it. So you just need to mention the entry point inside a metadata, and that should work for you. Another point that I want to point out here is that if we said that it runs on the main thread, the content provider all the time, but there is a possibility for you to actually trigger your content provider on different process. I don't recommend this, but basically you can specify a process. But because as you start doing multi-process things, a lot of things can go wrong, and then there's like a lot of bunch of problems that you have to deal with. So, but there's a possibility. You can definitely do this. So what if I want to disable the initialization? Well, typically, as we already mentioned, we can remove the initial the node specifically, but because this is specific to AndroidX startup, what we are going to do is that we, instead of removing the whole provider, the node remove marker actually goes on the meta tag. So once the meta tag is gone, the app startup doesn't know which library to initialize anymore, and so it works totally fine. But you might, as an app developer, have a different reasoning. You could be like, I really just need to stop the app startup or the AndroidX startup library from initializing any library, like, because the libraries have dependency on them now, right? So you want to get rid of all of these initialization. For some reason or the other. Maybe it's because you think that having AndroidX as startup is slowing your application down or is doing something, so you just don't want anything to run at all, right? So in that case, in that specific case, you will add the remove marker on the actual provider itself and not on the metadata. And this basically just disables everything out. The AndroidX startup content provider also is never injected, and AndroidX startup is not doing anything. Well, because nothing is starting up anymore, how do you actually initialize your libraries which are using some sort of an initializer? That's when the manual override comes in. It only works when you have already disabled the provider, the provider, and this also enables you to lazily initialize a particular library. You just say app initializer, this is a class that's available to you, you get the index instance, and then you initialize the component passing in the class for that initializer. So what this means is that eventually you could actually have jumped to a different process and just call this on your own. Maybe if you wanted to go to a specific screen and just trigger this line, you would have initialized the library at that point in time. And so that's why it's lazy initialized. And you don't have to actually worry about how things are getting triggered on their own. You basically stopped all libraries that were using AndroidX startup to start up on their own. You are in control, and you are able to initialize whenever you want to do it. This is not something that you should be doing quite often, but because it probably is not an intended thing, but it is a possibility that allows you to do this. Some library developers would kind of block this, but Let's hope that's not happening out there. So how good is it? Well, typically, let's say these are like the pros for this. Like it allows you to do the dependency init in order. You can define the dependencies. There's also lazy initialization that we already talked about. Good thing is that there's only one single provider now being triggered instead of like say 5 of them, considering all of them are using AndroidX Startup. It does have lint checks, which is nice. However, the cons in this case is that it's still using the content provider trick, which is abusing content provider. Well, it's better, but it's not the best. It's still using something that's abusing the content provider. There is no support for asynchronous initialization. It's part of the library structure. The developers did not want to open that up, at least up till now. There's no multiprocess in it. That's also part of the design. But hopefully, if that becomes a requirement, it might get updated soon. There's a bug tracker that you can check out. Not a lot of bugs there. Most of them are like something related to very specific to a particular application or a library. But in general, it's not like a big problem. But if you do actually want to check it out, you should go ahead and file any bugs on the issue tracker. So are devs actually using this? Well, the short answer is yes. Like for example, there are some libraries that I could find out. It's like What the Stack, Sentinel, Phone Emoji. There's Retro, there's TikTok. All of these libraries I actually started using the AndroidX Startup. A lot of like closed source libraries also use this. I can tell you based on my personal experience, and they all use this because it is a better version than what they were trying to do before, and trying to compete to initialize on their own. So what's next? Well, the first thing that needs to happen right now is that the AndroidX libraries need to be migrated to use Jetpack Startup. Why? Because they are widely used than any other library out there. There's like a lot of people using Work Manager. So a lot of people using Process Lifecycle Owner. And then there's a lot of people using Firebase, and they all need to actually start using Jetpack Startup, but they are not. Hopefully that happens in the future. And another thing that needs to kind of happen is that more library devs start using Jetpack Startup. Lot of them are using this. As I mentioned, there are like some libraries that would make sense to actually initialize later on, then start up on their own, just so that they could get rid of or they could get the context when they're initializing. So hopefully this changes over a period of time and more library developers start using the Jetpack Startup. All the examples I actually showed you are there on our GitHub repository. You can check that out. It's on github.com. Initials is my username, and then Android lib init examples. It covers the sections that I mentioned. How do you initialize a library using a constructor, init function, LifecycleObserver, Singleton, ContentProvider, and then finally using the AndroidX Startup. The one thing that I could not actually cover, and obviously there's not enough time to cover everything out, is that something that like we mentioned how these libraries are starting up and maybe causing a bit of lag in your application, and also from the library developer side, like how you are actually disrupting an application. But we did not talk about like how do you benchmark or how do you read what that performance degradation is happening from. Like what is the time that it takes for your app to start up with the app startup, with the standard content provider setup of the library, or by removing the library completely and using lazy initialization. So these all three cases needs to be benchmarked. A performance check needs to be done, right? So the general idea though is that you actually use the ADB, and then you bridge over to your application, and then considering the way that you have set up your library, so considering, say, you have set up with manual initialization, right? So you run your application, you kill the process, and then you start it again, and then you check the time difference between, and then you see that how much time it took for your application to actually start up from the clean slate, right? Now, again, as I talk about this, it sounds like it's easy, but it's not that easy. There's a lot of things that you need to do. You need to lock the clocks and do a lot of things. So that's why I am actually linking to a blog post here, which Chet Hase, who's from the Android Tools team, actually wrote about. He's written Testing App Startup Performance, and he actually goes into proper detail of explaining how to do this stuff. Internally in closed source applications and closed source SDKs, we have been doing this with our own personal scripts. But the version that Chet Hase actually talks about is very specific, and he kinds of explains in a very generic manner with a good description. So definitely go check out that blog post, and then you will actually be able to justify taking a certain approach. Like, do you want to do a talk with your company for that. And I guess that's all. So if you have any questions, please put them in the chat or wherever. And also you can reach out to me on Twitter with the same username as earlier, NISRULZ. And you can find my website, and obviously you can reach out to me on my email, the same username. That's it. Thank you.
All right. Thank you very much, Nishant. Also a very interesting talk, and I especially liked how you motivated the AndroidX startup to like go through building up the content provider as a way to solve it, sort of elegantly, just to deconstruct it and to say, no, this is the wrong way, and to say that basically in the hood we do it the same, but we manage it in a smart way. So that was a very, very nice way to really see where the values of the AndroidX provider, and where it's motivated.
Yeah, the thing is that a lot of actually library developers as well as application developers kind of see this, but they don't know that there's a hidden thing that's happening behind the scenes. And I think when you start looking at something that you already know, like when you look at the dependency and you can actually notice there's a Jetpack startup there or AndroidX startup there, you actually start now connecting the dots, and then it makes more sense to you. So I think this in general is something that I think more people should get aware of, and eventually I think even the team who is building this AndroidX startup library, they are definitely open source, so you can go ahead and file issues. You can ask for feature requests or something. If it makes sense, it will actually evolve the ecosystem in a better direction. So hopefully more library developers use this, more companies actually start doing this. I want Facebook to start using Jetpack Startup, because that's like a common thing that I get from when I'm working with companies, and they are always like, so we know that Facebook is starting up at the start of the application. How can we disable it? And I'm like, we need to start thinking about something else. Let's start looking at something that they are doing, and then they are like, oh, we did not know this actually is happening. So I'm hoping that things will get better.
Cool. I think we had some trouble with the video connection towards the end. So maybe if you could repeat the wrap up that you had, the summary. So it was until the part with a blog post that the Medium post that you referred to, and then we had the last slide again, but like the part in between, if you could just fill that in.
Yeah. So I think what the summary of this whole thing was that we have been talking about how these libraries are actually starting up and like what they are, the different things that they can do, but how do you actually measure that they are actually affecting your application startup, right? So benchmarking is something that you would want to do. You want to understand how much time it takes with the library, with the standard content provider that they are using, with the library using a Jetpack startup, and with the library not starting up on their own but using a manual initialization. And this as a whole is something that Chet Hase actually talks about in his blog post. He kind of goes through locking the clocks and figuring out how to measure this time when you start using a certain version of initialization of the library, and then you see the dip, or you see the difference between the time that it takes. So all of that process is something that I was suggesting mostly that people go ahead and read that blog post. It's a very good write-up. There's also there are two more blog posts that he connects from there onwards, which also talks about Jetpack Startup, and he kind of explains the reasoning of how the measurement actually should drive other library developers' interest of integrating Jetpack Startup. So yeah, that's the general part I think that got missed. But other than that, I think the most of the part related to the Jetpack Startup was basically saying that start using Jetpack Startup. Stop reinventing the wheel and using content provider on your own. Just start using Jetpack Startup.
All right. Yeah. That's the gist that certainly came over from the whole presentation.
Yeah.
So did you like do some experiments with measuring the time yourself, and do you have any insights about the different ways of initialization, and like with a singular content provider like manual, or with a library, or with a different entry points within the class with the initialization or the singleton? Do you have like a rough comparison of from performance side?
Yeah. So that's a very good question, actually. So in general, a lot of the code that I've been working is mostly closed source. Closed source. So what I would want to maybe bring up is that if you did manual initialization on demand, so considering, say, you are on a certain screen and only then you want to use the library, you should do the manual override version that I was talking about in my slides, and initialize your library manually. That takes the least amount of time to start up and everything. And um, if you did say something with the Jetpack startup to start your library on its own, when the app starts up, that takes a bit more time. We are talking in milliseconds, so I can't give you like an exact number, but think of it's like it's a bit more, like say 20% or something like that. I think it's like 2 milliseconds or something. It's like super low, but it adds up. Considering if you have many libraries, then it adds up, right? So that's why manual initialization is something that people should prefer more. Then they should go for Jetpack Startup, and if that also doesn't work out, then the content provider is basically everyone starting on their own, and that's like they're gonna slow down your startup considerably. In terms of like using Singleton or a standard constructor or a lifecycle observer, again, there are many ways of doing this. They have their pros and cons all the time. But as soon as we start talking about something that happens automatically, that's when actually things get worse. So an object is statically created, and it will be basically called init will be called later on, but it will create some allocation, so that also adds to your performance. But if you created a standard constructor, you are deferring the initialization on your own at a certain point in time, so that's equivalent to the manual initialization I was talking about. So that's easier, and it's also not as much allocation on your memory, and also better on your performance. And then obviously the lifecycle observer version I was talking about is also a deferred version. It waits until your on starters calls in an Android. So that particular case is also an on deferred version, much preferred, has a lot of boilerplate, and you have to add observer, remove observer. So some tricky stuff with pros and cons. Yeah, but in general, doing things on demand is mostly preferable than doing them automatically. The automatic things makes it easy for integration, but it does brings its other cons with it overall.
Okay, wonderful. Thanks for answering the question. We have 5 minutes still left, so please post the questions. And while everybody is typing frantically to be the first to put in the question, I'm gonna use that time to play devil's advocate. So
Okay.
you already have 4 ways to initialize it, and
Mhm.
you have, like you mentioned, this big chaos, and now you have yet another way to do it. And if the community takes it on, perfect. Then you have the one way to do it, and everybody is super happy with it.
Yeah.
But it might end up yet another way to increase the chaos of the ecosystem, and to have like this whole chaotic who sets up what at what time,
Yeah.
if it's not used consistently in the community. So maybe if you can remark on that.
Yeah. So again, that's a very good question. As it is with the so apps is applications, when they are getting developed, you don't see the code for them, right? Like you're basically delivering them to the users, and they just see your application. What happens behind those view layers is something that people can reinvent. They can do anything, and then you have, that's why you have so many architecture patterns. You have MVC, MVI, MVV, VM, and then there's like a presenter pattern also. So all of these, like these patterns is how you should represent the library version also, right? So the initialization patterns um, are many, and I actually certainly did not cover a lot of them. I covered the most common ones. There are definitely many different ways. um, Picasso, for example, does use content provider, but it does not do it directly. It does a bit of a tricky version, so I did not mention Picasso using content provider right away, because it does a unique trick. So that's why a lot of people would reinvent the wheel, and they will kind of do a lot of different ways. The idea is that eventually everyone converges onto a standard, but there is no standard, right? So the only way to do that is that if the AndroidX team pushes for it, and that's why the push is for the AndroidX startup library to be embraced. But not a lot of people would do that. That's definitely there. There's no answer to the sense that can we avoid this overall. uh, we can push for it. We can start talking about saying that this is a better alternative. If you are doing something like this, here is another alternative. The whole reason of doing content provider was that people had no other option of doing this in some other way. They are abusing content provider. So that's when the community, or at least the AndroidX team, decided that okay, we're going to take this whole big problem that's there all over, and we're going to try to solve this in some other way. So that's why the AndroidX startup came to be. And overall, like the singletons are still going to be used. I said Coil is still using it. The standard constructor is still going to be used. All of these are something that you can't stop them, but you can kind of suggest people to start using a better version. The same way as it happened for architecture, as we said, that initially people were building so many different architectures, but when the tools team and the AndroidX team actually started pushing for it, most applications now start using MVVM pattern. So the idea is that we want to push for it. We want more people to start using this, and overall, I think when they start seeing the benefit of this, when they start seeing numbers for this, if they did calculate the performance and how much time it takes for the startup, I think the idea is that they will all opt into this. They will start using this, and then it becomes a standard, and more people start using it. So we can only hope for it, but the idea is that it happens. It happens at some point in time, or someone comes up with a standard that everyone agrees to, which is not happening soon.
No, we all know how difficult it is. And if I understood it correctly, it was launched just 3 months ago, and so there's still very, very early on. So there's still the possibility that gets a lot of traction. Everybody takes it up.
True.
So thank you so much, Nishant. It was great to have you. There's been a lot of praise in the comments as well for your talk. So it seems to really been very valuable to people and resonate well. So thank you, and oh yeah, if you think of another question that you would have wanted to ask, then ask the speaker at Dachfest Online. Yes. Don't forget to send an email. We'll forward it. And without further ado, I wanna say thanks and goodbye.